hello, we're back on part 2. And as you saw from part 1, our conclusion was the tension in the wire on the first wire, T1, was 95 newtons, and the tension in the second wire was 130 newtons. Alright, so that was day 1 work. Alright.
Felt like day hard.
Alright, after day 1, we learned how to work with elevators, and we had the man. How often do you see this? A man standing on the scale on the elevator?
Pretty regular.
Yeah, right. So you have to be prepared for this in life. So we have a 72 kilogram man standing on a scale in the elevator. And the elevator travels upward, but it is slowing. So this is day what? Elevator problems were on day 2. So you probably have room on that because we didn't do much. Oh, we did do all those drawings. Do you need extra paper
I have it on the back.
for day 2? It's just an example that you can use, fit it in somewhere on your day 2 notes. Do you have any of those notes floating around in there? Let's see where they are. It's mod 6. You need dividers, boy.
Yeah, I took them out
Alex, we have to organize that again.
Why did you take out your
because
dividers?
like, my binder's messed up and it has like a crack thing over here and
Yeah.
it's cracked
I can't handle
too.
this.
So they give you binder and you
No,
add
I
everything.
know.
Alright,
No
well,
excuses.
There you go.
Ruined all of it.
I think it's coming apart.
Alright.
And you need new binder.
So if you would sketch the essence of this problem, 72
The
kilogram
essence.
man, and it mentioned in the problem, you don't have to write every word, but mention the elevator is traveling upwards, but it's slowing down, which happens, so you approach your floor. And at that point, the acceleration is negative 0.84 meters per second squared. And I'm sure you're wondering, what would the scale read at such a moment in time? To do this kind of problem, you will recall that the sum of the forces is ma. So what forces are working on this man? There were only 2. One was his weight downward. What was the other one? It's actually the one the scale reads. What is, so he's not crashing through the floor. There's something countering his weight. What was it?
Gravity.
This weight is basically caused by gravity. So what is that force that is opposite gravity when you're not crashing through the floor? It's the force that's holding me up on the floor, you up on your chair right now, and so forth. It is
Friction.
not friction.
Okay, I don't know.
Force normal.
Oh yeah, that one.
Force normal. That's why we're reviewing.
Got this.
It's been a
Oh,
long
I
time.
looked at my notes and I was like, oh yeah, FN. That's-
All right,
duh.
so there are 2 forces acting on this man who's standing there. So it is going to be his weight, which is downward, and force normal, which is upward, equals ma. Now, we learned when we talked about the elevator, the actual number that the scale reads is force normal, which I always felt like when I was standing on the scale that my weight was being measured, but actually it's the scale's pressure on me that's being measured, which is force normal. So I'm going to solve that for force normal like we did that day. I put it in the front, and this is the equation that will get us the answer. So force normal is what the scale reads. So the scale is connected to force normal. The weight we have to calculate because this is mass. So what will we do with the 72? We will multiply it by acceleration, weight equals mg. So we get weight equals 72 times 9.8. And I guess I didn't write that down. So 72 times 9.8 plus mass 72 times acceleration given in the problem, negative 0.84. So when you calculate that, you will have what the scale reads. Tap it away.
Tippity tap.
Tippy tap. So force normal and what the scale reads is what? Are you there yet?
No.
Are you there yet?
Yeah.
Are we there yet?
You should be with your day 1 notes, your day 2 notes, so give you another.
Knowing me, I'm gonna get the simple
Paper.
edition wrong. Yeah.
when you organize your notebook. So all you need is a new notebook, you're saying?
Yeah,
When
because
you
I took
organize.
some of the papers out, 'cause it was like falling apart, and I was like, yeah, I need a new one.
Okay. Alright, are you getting, after you tap it out, are you getting 650?
6:45.
Yeah.
I got so much.
645 with
This
two
actually
sig
describes our
figs.
class.
Do you see that 645 becomes 650?
Yeah.
Okay.
I don't get it.
What'd you do?
It's good, Emma's asking me all the time.
And so 650 is what he sees on
How
the
you
scale.
How did I get 1.6?
You got 1.6?
Instead of, yeah, whatever. Sorry.
So what are you?
Okay, I think I got it now.
Alright, we went from the yellow problem on tension to the white problem on the elevator, and we ended with torque. So let's go there and review, and then you'll be able, that's where we were actually working on Friday, so
Oh, my
Friday, many Fridays ago. Torque is created by any force. So anytime you have a force that creates, and you have an axis of rotation, it creates a circular motion. So torque equals force, perpendicular, and we only count the perpendicular force. Force times the distance from the axis of rotation, which we called r, like a radius. So that was our equation for torque. So we expect to find a torque everywhere there's a force and an axis of rotation. We just sketched this scenario. There's a scaffold that is a platform on ropes that is pulled up the side of a building for a painter or window washer or something like that. Anyone ever stood on a scaffold?
No.
Have you?
Too no
Bad things happen in movies.
Alright. Well, this scaffold weighs 150 newtons on its own without anybody or anything on it, and it's 5 meters long. So as you sketch it, indicate the important information. And this is day 3 notes, so you need extra paper for that. You should have some room, although we've done a lot of problems. Anyone need day 3?
Do you not have this? Do you not have
Okay,
day
so
3?
write day
Do you have
3
that or not?
on
It was
that.
on 12/16. So.
We're
We'll do day 3. You didn't get your days.
No, I
Three.
think
So
it's
write your day
Yeah,
2.
you
we did.
Alright, well, skip
I
to
just don't
day
remember.
3. I'll leave day 2 up for you. You find a spot or you need more paper?
I got this.
Okay.
I have a whole back to work with.
Yeah, there should be some room.
I always called the thing too small.
I'm not sure how you organized your work last school week we were here. Now we gotta add a worker. We're not just gonna have a scaffold, so certainly.
Is that a code word for something? Like,
It's I
So
love
start on
It's
your
just the
third day.
what is scaffold?
It's like
A
the little
scaffold
a platform.
is a platform that's hung by ropes or wires, and it goes up the side of the building. A painter and a window washer will stand
Yeah.
on it. Not very secure, is it, Brian? It doesn't feel secure.
No, too many bad things
It
happen in
is
movies on
secure,
this.
so day 3.
Wait,
iCarly, have you ever seen the iCarly
this
episode?
man
Where she falls?
weighs 600 newtons,
Throw.
Don't read into it.
600 Newton man, yeah.
and he's standing on 150.
Newton scaffold.
Wow.
That's what the problem says.
No, not everyone.
I'm not, who am I to
Very
argue?
reliable.
On
So,
which end?
we calculated how many newtons are in a pound, right? Once,
What was it, like-
4? So
I thought it
when
was
you
like
divide
2.
600 by 4
1300 down.
would be
did?
his weight in pounds. Does it make sense?
150.
150, that makes sense, Zach.
What?
If a
Yeah.
newton is 4 pounds, it makes sense. All right. So, I mean, if a pound is 4 newtons. All right, we've calculated that sometime in the past, but 150 newton scaffold, the 600 newton. Notice I put a decimal there indicating all 3 of those digits are significant. And we'll put a 0 here. We're working in 3 sig figs here in this new year, so go figure.
Go big.
So I want you to
Go home.
find the tension in each rope here. So let me draw in the rest of the problem. There's a worker. This whole thing is 5. So I'm not going to put all my sig figs in. It's 5 meters. And I'm going to put the man on this end, 1.2 meters from the end. There's a man.
I would not get that close.
I know. It's like
And He is 600 newtons. And the question is find the tension in each rope. So when you find the tension in each rope, then you can see if your rope will hold that much tension. So you'll be safe. So once again, our governing equation is the sum of the forces equals Ma. And now the sum of the torques equals Ma. Torques also follow Newton's second law. We're hoping that the acceleration is 0 and that this thing is not rotating in the air. So we're going to call the MA part 0 for this problem. Let's do a statement about forces first. So how many forces? I'm going to do an equation for forces, then I'll do one for torques. Forces.
Freezing, dude.
Do you see? How many forces do you see? Could you sketch them on your picture with arrows for forces that you see in this problem? In a moment, I will add the forces. See if you found them all. So draw the scaffolding and add the force arrows.
How many? Wait, how many? 4? Maybe? 1, 2, 3.
How many forces are you observing in this
There's
case?
just 3. No, there's 4.
Here's one you should all get,
This
is the
up,
weight
this
of the
This
man.
thing down, the weight of the man.
All right, the weight of the man is the force. Then we have 2 ropes here. Remember, ropes form tension the other way from the object. So we have it, I'll call that one tension 1 and this one tension 2. And there's one force I left out. Did anyone catch it? Which one, Emily, 2?
Can you stop?
Dramatic pause while we wait to answer that question.
Okay, goodbye.